So, today I will discuss about the compound pendulum. So, using compound pendulum, how we can find out the acceleration due to gravity and also the radius of gyration. So, this simple pendulum from a support with a thread, massless thread, we just hang a mass m, right. Then its time period is basically, you know, this t equal to 2 pi square root of L by G, right. Now, compound pendulum, say any body, if you, so irregular body, it can be irregular body or regular body. So, it has center of mass, of this body, say the center of mass is this one, this is the center of mass G, okay. And is the suspension through a point, say here point P. So, axis passing through this point P, it is a horizontal axis passing through this point P. This is the point of suspension of this body. So, with respect to this center, with respect to this axis, horizontal axis passing through this P, so this body can oscillate, Then we tell this is the simple compound pendulum, right. So, when it will oscillate, then there will be restoring force, and due to this restoring force, basically it will oscillate. So, this theory of this compound pendulum is, so what is compound pendulum? A rigid body mounted upon a horizontal axis so as to vibrate under the force of gravity is a compound pendulum, right. So, this, as I told, this point P is the axis of suspension, G is the center of gravity. Okay. Now, this gravitational force will act downwards, this mg, if m is the mass of this body. So, then this if you if you just connect these two P and G, so this length is say L, small l, and now this is the, you see, if you extend it. So, whatever the angle with this gravitational force, if that is theta, then you can resolve this force along this P G. So, that is basically it will balance the this, it's the weight along this direction of force along this direction. So, that is m g cos theta, and another force perpendicular to this P G. So, that will be m g sin theta. Okay. So, that m g sin theta is the restoring force. So, this is the force and this is the distance with respect to this p, that is the distance L. So, torque will be mg sin theta into L. So, torque will be mg L sin theta, and this negative sign, which is a restoring force, it is working in this direction against the displacement, or yes, change of theta. So, this torque is, we can equate with this I d2 theta by dt square, like m d2 x by dt square. So, m is replaced by I, as I mentioned earlier. So, this is basically moment of inertia. It is the moment of inertia of this body with respect to the axis passing through P, horizontal axis passing through P. So, that is the moment of inertia. So, for small angle theta, one can write sin theta is approximately equal to theta. So, this equation of motion is theta double dot plus mgl by I, this sin theta is theta equal to 0. So, this is the equation of motion. This is the simple harmonic equation, differential form of this simple harmonic motion. So, this part basically theta double dot plus omega square theta. So, omega square is mgl by I. So, omega is 2 pi by t, right. So, 2 pi by t whole square equal to mgl by I. So, from here, from this relation, one can write t equal to 2 pi square root of I mgl. Okay. So, this is the time period of this compound pendulum when it is oscillating, with respect to the axis, horizontal axis passing through point P. This is the axis of point of suspension, and distance between this point of suspension and the center of gravity is L, and I is the moment of inertia of this body with respect to the axis passing through the point P. Okay. So, so from parallel theorem, I one can write moment of inertia of center, moment of inertia about the axis passing through the center of gravity g, which is parallel to the axis passing through the point of suspension. Okay. So, axis here and axis here, they are parallel. Okay. So, the moment of inertia with respect to this axis of suspension is I is equal to the moment of inertia about this axis passing to the center of gravity. So, that is I g plus m, mass of this body m, and this distance squared. Okay. So, this comes from parallel theorem of moment of inertia, and then I g is basically it is the m k square. I g is m k square, and this k is called the radius of gyration. K is the distance. Okay. Moment of inertia about g, okay, axis passing through the g, which is parallel to the axis passing through the p. Okay. So, this is equal to the m k square, this k is the radius of gyration. So, from this experiment, our aim is to find out the acceleration due to gravity, basically g, and also the radius of gyration k. Okay. So, So, we know that T equal to now T equal to 2 phi, that I is replaced by m k square plus m l square divided by m g l. So, from here you can write 2 phi square root of k square by L plus L divided by G. Okay. So, as I showed you that time period for a simple pendulum is 2 pi square root of L by G. So, if we compare these two, so as if L is this, okay, L equal to k square by small l plus L. So, when L is this, then that means this L is different from the small l. Small L is basically distance between the axis of suspension and the center of gravity, okay, this small l. Now, this L is a new L, this L is a new L, it depends on L as well as it depends on radius of gyration. Okay. So, this is a quadratic equation of L, we can write this L square minus L capital L small l plus k square equal to 0, quadratic equation of L. So, it will have two solutions, say L 1 and L 2, such that this L capital L will be has to be equal to the L 1 plus L 2 and k has to be equal to the square root of L 1 L 2. So, this is the quadratic equation and its solution is has to be such that it has to follow this one. Okay. So, from here basically this equivalent. So, this equivalent this L is called basically length of equivalent simple pendulum, length of equivalent simple pendulum. And if all masses, what is the meaning of this equivalent length of equivalent simple pendulum? Means if all masses centered at a particular point P, this distance from this P, not P, this O centered at O, its distance is capital L from the point of suspension. Okay. Then this this will be equivalent to a simple pendulum. All mass concentrated at this point P, distance is capital L from P, and this L is basically square root of k square by L plus L small l. So, so then it will behave like a simple pendulum, it will oscillate with the same period of simple pendulum. Okay. So, that will be the basically equivalent, this is reduced to the equivalence of the simple pendulum. So, what from here, so what we are getting basically comparing with the simple pendulum. So, this O will tell this is the center, is called the center of oscillation. Okay. This O is called the center of oscillation, G is center of gravity, P is the point of suspension. So, this distance from P to G, that is small l, distance from P to O center of oscillation, that is capital L. Okay. So, now this from this relation L equal to L 1 plus L 2 and K is square root of L 1 L 2. So, L and L 1 and L 2 both has to be positive, both has to be positive. Okay. Both has to be positive. That means there are two positions. What is L? L is basically L 1 and L 2. So, there are two positions there are two positions of P about which T are same, because two solution of L and L is basically distance of point of suspension from the G center of gravity. So, there will be two positions of P, okay. There will be two positions of P about which the time period will be same. Okay. So, that means there are two positions, one will be from G, one will be L 1 and another will be L 2, and similarly if you go other side to the center of gravity, if point of suspension in other side. So, then your there will be two other points, of suspension. Again you will get basically two value of L 1 and L 2. Okay. So, there also time period will be same. So, basically with respect to the center of mass, point of suspension from this left side 2 points and also right side 2 points, these 4 points will have the same time period. So, if you plot this time period, if you measure time period for different point of suspension, from both sides, from one side of the center of gravity. So, if you plot this time period as a function of distance or as a function of distance of point of suspension from center of gravity. So, distance of point P from G. So, that is basically we are telling L. So, distance. So, it will this graph you will get like this, Similarly, on the other side of G, if your point of suspension if you vary, so you will get symmetric curve on the other side. Okay. So, this is the time period, this axis is time period T, and this is the distance of point P from G, this side in one side and this side the other side, okay, point of suspension the other side. So, here if you just draw a line parallel to this distance of P from G. So, it cuts this graph in 4 points. Okay. So, this is basically center of the C, center of gravity. Okay. So, point P 1, point P 2 in one side. So, this C P 1 that is basically L 1, on the other side C P 1 dash that is also L 1. Okay. And C P 2 will be equal to C P 2 dash, that will be L 2. Okay. So, basically for these 4 distances time period will be same, this is the time period. So, for a particular time period we will get 4 point of suspension, okay, 4 point of suspension, 2 is one side of the center of gravity and 2 on the other side of the center of gravity. So, if you plot graph, then from the graph you will get basically you will get L 1 and L 2 value. So, if you get L 1 and L 2, then you will find out capital L, L 1 plus L 2, and you will find out radius of gyration k equal to square root of L 1 L 2. So, our experimental task is to measure time period T, for each distance, okay, of the point of suspension in one side of the center of gravity and as well as on the other side of the center of gravity, right. Then when you will plot the graph from there, you will find out L 1 and L 2, okay. And then you will find out capital L, and from capital L you will get basically G value, because time you are measuring time period T and you are measuring basically also you are getting capital L. So, from there you will find out this value of G, and K directly you are getting from this relation L 1 square root of L 1 and square root L 2. Okay. So, what you have to measure? So, then let me show you this table. So, table 1 will be data for T versus distance L from the center of gravity of the suspension point P. So, for this, so you have to note down the least count of stopwatch you will use, and then least count of meter scale you will use for measuring distance. And in our bar simple compound pendulum. So, we have made some holes on this bar. So, distance between two holes equal to 5 centimeters. So, this whatever the information you should note down on the top of the table. Then serial number of holes. So, holes 1, 2, 3, 4 from the top. Okay. So, note down the distance L of hole from center of gravity. So, that is say 47.5 say. Then next one, just you are reducing, so you started from the top end and now coming down towards the center of gravity. So, this its difference is 5, then next one will be 37.5. So, this you will go till up to close to the center of gravity, and then other side of the center of gravity again you should do the experiment taking starting from the say top end of the other side. So, again that will be around 47.5 and then 42.5 etcetera. Okay. So, you should note down the varying the distance of point of suspension from the center of gravity. So, this from one side and this is the from other side, and for each length L find out the time for say 30 oscillation. Okay. So, and then 3 times you should do and then take average of it. So, from there you will find out the time. So, you are finding out basically time period T and corresponding that distance from the center of gravity of the point of suspension, that is L. So, that is what you need for drawing the graph. So, now then you should draw the graph as I showed you. You should draw the graph. Okay. You should plot time versus this distance of P from the center of gravity. So, if you plot, so from plot you have to find out these 4 points, you have to find out 4 points, then you can calculate the G value and radius of gyration K value. Okay. So, then next table for calculation of G value and K value from T versus L graph. Okay. So, here so basically you have to find out this from this graph. Okay. You have to find out L 1 and then L 2, then from there you will calculate L. So, which one L 1 and which one L 2, that already I have told you right. So, from center C here that these 2 points you will get. So, take the distance of these 2 points from C, also you take the distance on the other side, okay, C P 1 dash and C P 2 dash. So, say that that I have here written this one side you take calculate and take the other side L 1 L 2 you will get, or one this way also one take this P 1 to P 2 P 1 to P 1 dash, that distance divided by 2, that will be L 1, and P 2 dash, that distance will be basically that distance divided by 2, that will be L 2. That way also one can consider. So, whatever the way you want to follow. So, just I think write this as a number of oscillation, number of observation. So, 1 and 2. So, in one case C P 1 and C P 2, that will be L 1 L 2, and other case C P 1 dash and C P 2 dash. So, that will be L 1 L 2. From there you find out L, and then corresponding time period already you have. So, write it, then you can get calculate the G value, right, and so 2 G value you will get. So, find out the mean G value, and of course, L 1 L 2 is known to you. So, you will get k equal to square root of L 1 L 2. So, again 2 value you will get, and then you take mean of these 2 value. So, that will be the basically mean k value, the unit is centimeter. Okay. So, I have written all unit, and you should this is very important, you should write it. So, then you will get value of G and K, and error calculation is easy, G equal to 4 pi square L by T square. So, delta G by G equal to delta L by L plus 2 del T by delta T by T. So, you know how this relation has come, I have discussed many times. So, it is very simple. Now, L directly you are not measuring L you are measuring from L 1 and L 2. So, you have to L equal to L 1 and L 2. So, delta L basically delta L 1 plus delta L 2, both are same. So, it is equal to 2 delta L, right. Similarly, T you are not measuring directly, T you are measuring T by 30 oscillation. So, one can write in general N, but we have taken 30 in our experiment. So, that is why. So, delta T by T will be basically delta small t by T. Okay. So, that will be the error on this G value, we have to find out delta G value. So, then result will be G plus minus delta G. So, that will be your result. Okay. So, similarly, on K is L 1 L 2 square root of L 1 L 2. So, delta K by K will be half delta L by L plus delta L 1 by L 1 plus delta L 2 by L 2. Delta L 1 equal to delta L 2. Okay. So, same value, in our case it is 0.1. So, L 1 L 2 for particular L 1 and L 2, you will find out delta K by K. So, from there you will find out delta K. So, your result will be K plus minus delta K. Okay. So, that is the way you should write the result. Okay. So, I think this theory one has to understand, then only you can perform the experiment perfectly nicely and calculate the results, okay, the G value and basically K value, radius of gyration. So, thank you for your attention.